Example 1 for RC circuits under Kirchhoff Law. The question is, a 100-volt electromotive force is applied to an RC series circuit in which the resistance of 200 ohms and the capacitance is 10 to the power of negative 4 farad. Find the charge QT on the capacitor if Q0 equals to 0. Hence, find the current IT. Given the equation governing the amount of electrical charge Q of the capacitor is R dQ over dt plus 1 over CQ equals to ET. To solve this question, first we extract the given information, which is R, C, and ET. Okay, we write here. Okay, R, C, and ET, right? We look at from the given question. We are given 100-volt electromotive. Okay, this is ET. Okay, so we can write here our ET equals to 100 volts, right? Then we are given resistance of 200 ohms. Okay, this is R. Okay, we can write here R equals to 200 ohms, and this is the symbol for ohms, right? Next, we are given capacitance is 10 to the power of negative 4 farads. So we can write this is C. Okay, so we can write C equals to 10 to the power of negative 4 farad. Okay, next the question is find the charge QT. Okay, so we can write QT equals to question mark. QT means the charge in terms of time. Okay, in terms of variable t. Okay, the charge at any time t. Okay, on the capacitor, if Q0 equals to 0, this is the initial condition to find the value of C. Okay, so we can write when T0 Q, which is charge, equals to 0, and the unit for charge is coulomb, right? Hence, find the current IT. Okay, so we can write IT equals to question mark, right? Given the equation governing the amount of electrical charge Q of the capacitor is R dQ over dt plus 1 over C Q equals to ET. Okay, this is the equation for RC circuit. Okay, that's why we have R and C here. Okay, R means resistance and C means capacitance, right? Alright, from this initial condition, we can find the value of C after integration, because when we integrate using indefinite integral, we will have plus C at the back. Okay, so to find the value of C, we need to use this initial condition, right? After we extract the values of R, C, and ET, then we can start with the given formula, okay, which is R dQ over dt plus 1 over CQ equals to ET. Okay, from here, we can substitute the values of R, C, and ET into this equation, right? So after we substitute, so we got this, okay, R we replace by 200, okay? C, we replace by 10 to the power of negative 4. And we replace ET by 100, okay? After that, we need to write coefficient of dQ over dt equals to positive 1, right? Before that, we can move 10 to the power of negative 4 from denominator here, we move up. When we move up using the properties of indices, we will have 10 to the power of positive 4. And 10 to the power of positive 4 equals to 10,000. Okay, so we have 200 dQ over dt plus 10,000 Q equals to 100, right? Next, we want to make coefficient of dQ over dt equals to positive 1. So what should we do? Okay, we need to dividing each term by 200, right? After we dividing each term by 200, so we got this, okay? dq over dt, 10,000 divided by 200 equals to 50. And then we have q equals to 100 divided by 200 equals to 0.5, right? From here, we can compare with the original linear equation under first order ODE, which is dy over dx plus bxy equals to qx, right? We recall back under linear equation first order ODE, the most important part is we need to find IF, which is integrating factor, right? And IF is given by e to the power of integration of px dx, right? So from here, we need to identify px, okay? When we compare with this equation, variable y is similar to variable q. Q means charge, right? Variable x is similar to t. Okay, t means time, right? px means px means pt, which is 50, and qx means qt, which is 0.5, right? So from here, to find if, okay, we can use e to the power of integration of 50 dt. Okay, 50 means px, okay, or in this case pt, okay, and we integrate with respect to t, right? So it is equals to e, and after we integrate 50 dt, we got 50t, okay? Alright, after we find if, we need to find the solution, okay? In this case, we need to find the solution q, because q is similar to y, okay? We recall back under linear equation, the general solution is given by y times if equals to integration of qx times if dx, okay? In this case, variable y here is similar to variable q, okay? So we can write q, okay, y means q times if, okay? If equals to e to the power of 50t equals to, we have integration sign here, and then we have qx, okay? From here, when we compare, our qx equals to 0.5, right? And then times if, okay? If equals to e to the power of 50t, and then dx, and dx is similar to dt from here, right? Right, and then on the right hand side, we have integration sign, so we need to integrate, okay? On the left hand side, we still have q times e to the power of 50t equals to, we have constant 0.5 in front here, and after we integrate e to the power of 50t dt, we got e to the power of 50t over 50, and then since this is indefinite integral, so we must put plus c at the back, right? After that, we simplify 0.5 and 50 here, okay? So we got this, okay? On the left hand side, we still have q times e to the power of 50t equals to 0.5 divided by 50 equals to 0.01 e to the power of 50t plus c, okay? We name as equation 1, okay? After that, we need to find the value of c, okay? Plus c here come from indefinite integral, because after we integrate indefinite integral, we must put plus c at the back, okay? And to find the value of c, we use this initial condition, okay? We substitute t equals to 0 and q, which is charge, equals to 0 column into equation 1. So we got this, okay? Q equals to 0. 0 times any value still equals to 0. And then equals to 0.01 e to the power of 0 after we substitute t equals to 0 here. And then plus c. Okay, and remember e to the power of 0 equals to 1. So we got 0 equals to 0.01 plus C. Okay, after that, we can solve for C. Okay, we have C equals to negative 0.01. Next, we substitute the value of C into equation 1. Okay, so we got Q times e to the power of 50t equals to 0.01 e to the power of 50t minus 0.01. Right? Alright, we recall back. We want to find the charge QT. Okay, so we need to write Q as a subject. Okay. In this case, we need to move multiplication of e to the power of 50t to right hand side. Okay, since this is multiplication operation, so after we move to right hand side, we need to dividing by e to the power of 50t. Okay, so we got this q as a subject equals to 0.01 e to the power of 50t over 50t minus 0.01 over e to the power of 50t, right? After that, we can simplify e to the power of 50t in numerator and denominator here, okay? And at the same time, we can move denominator e to the power of 50t. We can move up here using the properties of indices. So we can write the charge in the circuit at any time t, Q equals to 0.01 minus 0.01 after we move up. So we got multiply by e to the power of negative 50t. Okay, this is Q, okay, which is charge in terms of t, right? Okay, this is the answer for QT here, right? After that, we want to find the current IT. Okay, to find the current I, we need to differentiate the charge, which is Q, with respect to time, right? So from Q here, after we differentiate with respect to time, so we got the current in the circuit at any time t, which is I equals to dq over dt, and after we differentiate q with respect to time, it is equals to, okay, we differentiate constant 0.01 equals to 0, and then minus, we still have constant 0.01 in front here, and when we differentiate e to the power of 50t, we got negative 50 times e to the power of negative 50t. Okay, when we differentiate e to the power of negative 50t, we got negative 50 e to the power of negative 50t. But when we integrate e to the power of 50t, we got e to the power of 50t over 50. Right? Right. So after this, we can simplify this. Okay, we multiply negative 0.01 times negative 50. So we got I, which is the current in the circuit, equals to positive 0.5 e to the power of negative 50t. This is IT, means the current at any time t, right? This is the charge, okay, which is Q, okay? And this is the current, which is I, right? Got it? Coming up next, Kirchhoff Law, more examples. You can subscribe, like, and share to support this channel. Thank you for watching. Stay tuned. Bye. Assalamualaikum.